Alright, in this video I would be talking about TCP, uh, Transmission Control Protocol. These are the notes I made by watching these two videos. I will drop the links of these two videos in the description. So these are the things I've learned and I would be implementing whatever I've learned right now. Okay, let's start with TCP three-way handshake. Okay. Actually, I've used Claude as well to get these diagrams and text. So yeah, this is how a three-way handshake works. There will be two things, client and the server, and in between these are the things will be there like SYN, SYNAC, and ACK. SYN in the sense synchronous, ACK means acknowledgement, and yeah, let me describe three-way handshake in a simple way. If I call to a person and ask, hey, can I talk to you? This is sin. Okay. If the person responds, yes, you can speak to me, that is synac. And then I will start speaking whatever I want to talk. That is called acknowledgement. Okay. I have written here as well. Can we connect as you can? Great, connected. This is how a three-way handshake works. So there is something called UDP as well, and it is mainly used for live streams like that. So in that, like, I will just call to the person and I'll talk right away. I won't verify whether the person is listening to me or not. Okay. TCP is one of the reason why we have reliable uh, data transfer between client and server, because data packets won't get lost. They get verified actually, right? So I will open Wireshark. Let me open Wireshark. Okay. I'll open Mozilla Firefox. I'll just browse google.com and I'll capture the packets. Okay. I'll stop capturing and I will look into TCP stream. Let it be 19. Okay. All right. Okay. Uh, in this, we can see like the source, destination. This 10.0.2.15 is the IP address of the source, which means the client. Destination 142.250. This is the server IP address. Okay. And these are the port numbers we can see 59258, 443. Okay. Transferring between client to server, server to client, and then client to server back, like. And this is let me scroll this way, and we have delta time over here. Like delta time is like the time taken between the packets to transfer, like the time between current packet and the previous packet, basically how much time a packet gets takes time to travel between client and server. Okay. Okay, we can see this. I'll click on the 407 number. I'll open this and sequence number. Okay, sequence number are like uh, it is the number that will be assigned to the packets actually. I'll show you this example. If I want to send a 3-byte file, okay, so it will start with 1. So bytes from 1 to 1000. So between 1 to 1000, the first sequence gets delivered, and the second sequence will start from 101, like which is addition of 1 to the 1000, and then from 1001 to 2000 it would travel, and adding 1 to 2000, like 2001 to 3000. This is how data gets transferred, and this numbering will be given by the sequence number. Okay, this is a SYN file. This is the sequence raw number. Okay, and this gets added by 1 in the next file, the synac file. I'll click on this. Okay, You see, we get the acknowledgement number, okay, which is plus one of the previous one. Let me check again. The SYN file, the last three digits, if you look at 694, okay, the sequence number. And SYNAC file, we have 695, which is addition of 1 to the previous sequence number. And now we would be getting the acknowledgement file, okay. In the previous SYNAC file, we have this sequence number, right? 001. And now in the ACK file, it will be 002, the acknowledgement number, okay. So yeah, SYNAC, ACK. This is how it works. This is a TCP stream, by the way. I filtered it out with this. There are a bunch of TCP streams as well. And apart from this, yeah, this is how the diagram looks like. And the sender receiver sequence 1, that means we'll be sending 1000 bytes. It will be verifying that received 1000, and from 1001 it would again go back, right? And okay, apart from this, I've also seen about the window size. Window size is like how much size can we send it, like how much data packets we can send it. For this, it will be 64240. That means we can't send more than that. Okay, it leads to over buffer, basically overload of data. And there's something called TTL as well. Yeah, TTL, time to live. That means it'll say you the number of routers between the sender and receiver, okay. Generally this 64 is a default number for Linux, 128 it is for Windows. So generally, like, the number of routers are given by hops. So yeah, if there are 10 routers, so if I'm using a Linux system, here I'm using Kali Linux, so it'll be 64, okay. So if there are 10 routers, it will be 64 minus 10, which would give it like 54 TTL received. That means we should be suspicious, like there are more routers in the network, more than required. It might be a chance for man in the middle attack. Like the hacker is uh, disguising into be in the network in order to steal your passwords, data, etc. Generally happens when we log into websites with HTTP, you know which does not have TLS certificate. Okay, that's it. This is what I have learned. Okay, thank you for watching.